This question is from GATE 2015 Mechanical Engineering paper, set 2, question number 35. In a certain slider crank mechanism, lengths of crank and connecting rod are equal. If the crank rotates with a uniform angular speed of 14 radians per second and the crank length is 300 millimeters, the maximum acceleration of the slider in meter per second square is dash. Let's start by writing the given information. It is given that length of the crank is equal to length of the connecting rod, which we can see in this figure. This is the hinged end of the crank. This is the connection of the crank with the connecting rod. And this is the slider that is allowed to move in the horizontal direction. So as the crank rotates, due to the connecting rod being connected to the crank, the slider also moves in horizontal direction. Rotation of the crank is given by theta, and angular velocity of the crank omega is given as 14 radians per second. Length of crank and rod are given equal to 300 millimeters, which is nothing but 0.3 meters. We'll use all the terms in SI units, and that is why we have converted this to meters. We have to find the maximum acceleration of the slider. Maximum acceleration of the slider and not the angular acceleration of the crank. We actually have to find the linear acceleration of the slider. Acceleration of the slider is given as angular velocity of the crank omega square into length of the crank LC cos theta plus lambda into omega square LC cos square theta. Now here lambda is the ratio of length crank rod and the length connecting rod. In the given question, both lengths are equal, so we can write this ratio is 1. Also, to know how this acceleration expression is derived, you can refer to the NPTEL video that I will mention in the end. So by taking phi in terms of theta and then substituting this ratio LC by L rod as lambda, also using trigonometric series, this acceleration of slider can be derived. Now we have to find the maximum acceleration of the slider, A maximum. When will it be maximum? It will be maximum when this theta is 0 and the crank becomes horizontal. Hence we can write A max is equal to omega square LC cos 0 plus lambda is 1 into omega square LC cos square 0. Cos 0 is 1. So in both of the terms, we can put cos 0 as 1. Maximum acceleration will be omega square LC plus omega square LC, which is 2 omega square LC. If we substitute the values, we get the answer as 2 into 14 square into length is 0.3. This comes out to be 117.6 meter per second square. This is acceleration what we are calculating. So its unit will be meter per second square. We have taken length in meters. Don't forget to take length in meters. Let's fill in the answer. So the answer here is 117.6 meter per second square is the maximum acceleration of the slider. To learn more about slider crank mechanism and to refer to the derivation of acceleration for slider, you can refer to the NPTEL video, Module 4, Lecture 1, Balancing of Single Slider Machines, from the course Lecture Series on Dynamics of Machines by Professor Amitabh Ghosh. He is from Department of Mechanical Engineering, IIT Kanpur. I hope this solution will help you clear your doubt. Thank you.